Question says, a rocket is launched into the air. Its height in meters above sea level as a function of time in seconds is given by h of t equals negative 4.9 t squared plus 229 t plus 234. First of all, let's unpack the information that's given in this question. It says that this function is representing height as a function of time. That's why it says h of t right here. H is standing for height, and it's as a function of time. So basically that means that the height is based on the amount of time the rocket's been in the air. Height based on time is equal to, and then we got this, the actual function right here using t. So we put the number of seconds that the rocket has been in the air in for t, and work this out, and it should tell us the time. Now, like we've talked about before, like I talked about on one of the previous questions, the graph of a parabola, or the graph of a function like this, a quadratic function, is a parabola. Since this has a negative value for a, the graph of this parabola looks something perhaps like this. Okay? And the nice thing about graphs of parabolas that represent situations like this is you can almost think of the actual line of the parabola almost like the path that the rocket is taking. Now, of course, that doesn't mean that in this example, we don't know that this rocket is fired kind of along a path that where it's going to be moving sideways as it goes up and then back down. It theoretically could just be going straight up and then straight back down. But it is kind of nice to look at this path of the parabola almost as if it represents the kind of the path the rocket is taking. It's going up and up and up and up and up as time ticks by. Right, here's our time, here's our height based on the time. So it's going up and up and up as time ticks by. At some point it reaches its maximum height and then it starts falling back down to the ground. So question A says, how long does it take the rocket to reach its maximum height? So if this point here has two coordinates, like we sometimes call it an x and a y coordinate, although theoretically based on the way I've labeled this graph, it's actually a t coordinate, right? It's t and then the height based on that time. We are trying to figure out the time it takes for that rocket to get there. We're trying to figure out the x coordinate. And like I talked about on the previous question that I made a video for, to find that first coordinate of our vertex, all we're going to do is we're going to find out, so I'm going to put A down here, we are looking for this time, and we're going to find that by taking negative b over 2a for our equation that represents this scenario. So in this equation, the b value is positive 229, so that would be negative 229 for that negative b value. The a value is negative 4.9, so that'll be 2 times negative 4.9. And then if I simplify this, it should give me the amount of time it takes for that rocket to get up to its maximum height. That's negative 229 divided by negative 9.8. And so if I grab my calculator real quick and I work this out, negative 229 divided by negative 9.8, it gives me about 23.4 seconds. So it takes about 23.4 seconds for that rocket to get up to its maximum height. Then it says find the maximum height the rocket attains. So that would be the second part of this coordinate for the vertex, right? The x version, or the first part of that coordinate, is the time it takes for the rocket to get up there. The second part is the actual height at that time, which is what we're trying to find. So for part B, all we do is we say, let's find out what the height at 23.4 seconds is. So we're going to do negative 4.9 times 23.4 plus 229 times 23.4 plus 234. And again, I got to grab my calculator and I got to work all this out. So I'll do 4.9 times 23.4. That's going to be negative 114.66 plus 229 times 23.4 is 5,358.6 plus 234. So then if I add all these terms together, let's see, do that real quick, minus 14.66. Okay, so that gives me a height of about 5,470. It says 77.94, so we'll say it's about 5,478 meters would be the maximum height that our rocket obtains.